We're going to continue our discussion about nth roots and rational exponents. And so for this part of the video, we are going to be discussing what is a rational exponent and how is it related. So rationals, if you just look at that word, rational means fraction. So a rational exponent is also known as a fraction exponent. So all of our exponents are going to be fractions instead of integers or whole numbers like we are used to. And because a to the 1/2 power is a number whose square is a, meaning like if I were to take a to the 1/2 power and I were to square it, and using my properties of exponents, that would be 1/2 times 2 is equal to just a to the first power. So since a to the 1/2 power is a number whose square is a, you could say that if I took the square root of each side, you could say that a to the 1/2 power is equivalent to the square root of a. The same is true is if we were looking at a to the 1/3 power is equal, this is going to be equal to the cube root of a. Or if I had a to the 1/4 power, that's going to be equivalent to the fourth root of a. So in general, if you have something like a to the 1/nth power, that's going to be equal to the nth root of a. Try it. For this lesson, or in this section of the lesson, you're going to want a calculator. And I strongly encourage you. We know that if we were to just look at our calculator and we were to take the square root of 25, we would anticipate that the answer is 5. But a square root is equivalent to 25 raised to the 1/2 power. So I'm going to actually make sure that I put that into parentheses, 1/2 power, just to establish that that's my entire power that I'm raising it to. And once again, you're going to see that that is equal to 5. So there is a strong relationship here, a direct relationship between fraction exponents and roots. So a rational exponent does not have to be in the form of 1/n. It can be in the form of something like 2/3 or 4/5. So what that would look like is if we had a to the 2/3 power, that's going to be equal to, you notice that we had like square root, there was like an invisible 2 right here, and cube root, 1/3, the 3 was in the denominator, and 1/4, the 4th was the root that we were taking. Whatever the denominator is, that's the root that you're taking. And then the 2, well, that's going to be the exponent of what's going to be inside. So a to the 2/3 power is really equivalent to the cube root of a squared. Or if I had a to the 4/5 power, my root is going to be 5, so the 5th root of a to the 4th power. And that's how we would express it. So how do you remember this? Well, first of all, the thing to remember is that roots grow into the ground. So whatever the bottom number is, that's going to be what your root is. And then whatever your top number is, exponents always go on top. Your top number is going to represent your exponent of whatever it is that you're taking the root of. So if you have a base raised to a fractional exponent and you write out it in radical form, the denominator will be the root. Your exponent will be the exponent of your base. You might also see it with a bunch of parentheses. You might see that you're taking the root of your base, and then you'll have an exponent on the outside of a set of parentheses. So you might see this of base raised to the exponent divided by your root is going to be equal to the r root of b to the exponent power, or you might see it as the root of b, the rth root, whatever you want to call it, raised to the e power. In letters, a raised to the m over nth power. N is going to be your root, raised to the a to the mth, or you might see it with a bunch of parentheses. So to get started, let's go ahead and work with a calculator. So with our calculator, we're going to be looking at letter A. So in our calculator, I am literally going to put in 22 raised to the parentheses 1/4 power, and we're going to round our answer to the nearest hundredth. So that is going to make this 2.17. Let's go ahead and look at letter B. For letter B, I have 35 raised to the 5/6 power. Excuse me. Make sure I have parentheses around my exponent. And that is going to be equal to 19.35. And so what this means is that if we were to take the 6th root of 35 and then raise it to the 5th power, we would end up getting 19.35 as our answer. There are 2 solo questions. Please go ahead and try those and be ready to discuss them the next time that I see you. Let's go ahead and move on to the next page. So now what we're going to do is we're going to put our calculators aside. And one of the things that you will see on your quiz is that there's going to be a part of your quiz that's going to be a no calculator part. So we're going to evaluate these without a calculator. And the strategy that I would strongly recommend that you use, because we're evaluating without a calculator, use prime numbers and use all of the perfects that we listed in the very beginning of our lesson. So to recall, all of our perfects, we had perfect squares, perfect fourths, perfect fifths, perfect cubes. We're going to be using these perfects to help us with our answers. And if we can, we're going to write our base using prime numbers being 2, 3, 5, 7, 11, etc. Now, whenever you evaluate, we're not solving an equation, we're evaluating. So if we are taking an even root, doesn't matter, we're going to have no plus or minus in our problem or in the answer. And that's because we are not solving an equation, we are evaluating. So I'm going to write down that we are not solving an equation. So there will be no plus or minus. So we're not solving an equation. So this is how you do these types of problems. I'm going to look at letter A. And in letter A, I see that we have the number 125. And when I think of 125, what comes to my mind is that 125 is really 5 cubed. So what I'm doing here is I am replacing the base of 125 with the number 5 cubed. And I'm going to still raise it to the 2/3 power. So I just changed the base so that it is something that I can work with. And now what I'm going to do is I'm going to work with the properties of exponents. And the properties of exponents say that when you raise a power to a power, you multiply those exponents. So this is really 5 to the 6/3 power, which is really 5 squared, and 5 squared is 25. 25 is our answer. Now, if you can recognize that the multiplication of 3 eliminates the division of 3, giving you 5 squared, and we still end up with 25, that's perfect. If you can do all of that in your head, that's fine too. Just know that for these types of problems on a quiz, if you show work and it's wrong, you could get partial credit. If you show no work and it's right, you'll get full credit. If you show no work and it's wrong, you get no credit. So that is just something that you'll have to deal with and make a decision of what makes sense for you. Let's go ahead and look at letter B. Letter B, I see that we're working with the number 8, and I know that 8 is 2 to the 3rd power, and I am raising this to the negative 4/3 power. You can view this really as 2 to the negative 12 over 3 power. Negative 12 over 3, that is really 2 to the negative 4th. And because this is raised to a negative exponent, I'm not going to end up with a negative answer. We remember that negative exponents aren't happy where they're at, so you have to bring them down. This is really 1 over 2 to the 4th, and 2 to the 4th is 16. So my answer is 1 over 16. Let's go ahead and look at letter C. For letter C, we have 9 to the 3/2 power, and I know that 9 is really 3 squared, so I replace the base of 9 with 3 squared, and I'm going to raise it to the 3/2 power. Now, using that shortcut, we know that the multiplication of 2 eliminates the division of 2, leaving us with 3 to the 3rd power, which is 27. Let's go ahead and look at letter D. Letter D, I'm going to show you a couple of ways to view this problem. One way you could view this problem is you could say, oh, I know that 16 is really 4 squared. So I'm going to raise this a 4 to the 2nd power to the negative 1/4 power. So this is really 4 to the negative 2 over 4, which is the negative 1/2 power. But I still have a fraction exponent. So that means I need to keep going. So 4 is really 2 squared, and I'm going to raise this to the negative 1/2 power. The multiplication of 2 eliminates the division of 2, so this is 2 to the negative 1st power, which is really 1/2. And so 1/2 is our answer. That's one approach. Or another approach is you could say, oh, I know that 16 is really 2 to the 4th power, and I'm going to raise this to the negative 1/4 power. The multiplication of 4 eliminates the division of 4, leaving us with 2 to the negative 1st, which means that I have to bring that 2 to the negative 1st down, and I still end up with 1/2 is my answer. So just know that just because you might see one way doesn't mean that you're not, that means that you're wrong. You can view these problems differently. Obviously, the smaller the base is, typically that's going to give you a faster answer, but you're not wrong either way. The next few problems are pairs and solos, and we will discuss those the next time that I see you. Let's go ahead and move on to solving equations. So when it comes to solving using nth roots, we already did that a little bit on the previous page where we were, or a couple of pages ago, where we set up equations like these problems right here. We had something to the 5th power, so we took the 5th root of both sides, or the 6th root, or the cube root, whatever it is to undo that root. But another approach is you can work with fractional exponents. So to solve an equation of x to the nth power is equal to a, you could take the nth root of both sides, just like I just showed you in our previous set of problems. Or you can raise both sides to the reciprocal power, or the 1 over nth power. So what does that look like? So if I were to look at letter A and I were to solve this problem, I would start by dividing both sides by 6 so that I could get that x cubed alone. So when I divide 384 divided by 6, I would end up with 64. Now, look at what I'm doing here. You could take the cube root of 64. That's something that we could certainly work with. But what if that number was a different number? What if that number was like a 58 and it's not a perfect? One thing you can do is you can raise both sides to the 1/3 power. And now we're solving a problem very similar to what we did in example number 3. That the multiplication of 3 eliminates the division of 3, leaving us with x equals. And 64, I know that that is 4 to the 3rd power, and I'm raising it to the 1/3 power. The multiplication of 3 eliminates the division of 3, and I'm left with x is equal to 4. So this is just another approach. Like I said, you can take the cube root of both sides, that's fine. But what's nice is that if they end up with a problem that's not as nice as this, fractional exponents allows us to use our calculator. Let's go ahead and look at letter B. Letter B, I have x minus 8 to the 5th power. So what I'm going to do is I can take the 5th root of both sides, or I can raise both sides to the 1/5 power. Now I end up with x minus 8 is equal to, now 100 is a perfect. It's a perfect square. but it is not a perfect fifth power. And because it's not a perfect fifth power, what I'm going to do is I'm going to put 100 to the 1/5 power directly into my calculator. So in my calculator, I'm going to put 100 raised to the 1/5 power. And I'm going to close my parentheses. And when I do that, I end up with 2.51. So now I have x minus 8 is equal to 2.51. For these types of problems, I will allow you to use a calculator. So only in the example number 3 will I not allow you to use a calculator. But these problems I certainly will. So I'm going to add 8 to both sides, and we end up with the answer of x is equal to 10.51. Let's go ahead and look at letter C. In letter C, I want to isolate that x to the 4th power, so I'm going to start by adding 9 to both sides. I end up with x to the 4th power is equal to 40. Now you're right, we can take the 4th root of both sides, but 40 isn't a perfect in any way. It might even have like a factor of 4 in it, but that's really not going to help us in this particular problem. I also want you to recognize that if we were to take the 4th root of both sides, this is an even root that we are taking, an even root, and we're solving an equation, which means that I'm going to have plus or minus in my problem. So that is essentially what we're doing here in this step. So I just wanted to emphasize that when I raise both sides to the 1/4 power, this is really taking the even root of both sides. The multiplication of 4 eliminates the division of 4, leaving us with x equals plus or minus. And because 40 isn't a perfect, we're going to put this directly into our calculator. So I'm going to put in 40 raised to parentheses 1 divided by 4, and I end up with 2.51. So I'm going to write my answer as x equals plus or minus 2.51. I didn't mean to confuse you with what I did here. I just wanted to emphasize that you could take the 4th root of both sides. Absolutely. But how do you put the 4th root of 40 into your calculator? The way that you do that is you're raising 40 to the 1/4 power, and then you'll end up with an answer. And that answer is going to be plus or minus because we're taking the even root of both sides. Odd roots, you don't need a plus or minus, but even roots, you do, just when you're solving equations. When we were evaluating once again up here, notice I said there's no plus or minus because these are not equations. These are simplifying expressions, evaluating expressions without a calculator. We have one more example and then we are finished with this lesson. And that is the volume of a beach volleyball or a beach ball can be approximated by using the model V is equal to 4/3 pi r cubed. And these are problems that you learned when you were in geometry last year. This is where r represents the radius of the ball in inches. We want to estimate the radius of the ball if we are told that the volume is equal to 382 cubic inches. We're going to round our answer to the nearest tenth. So what I'm going to do is I'm going to let V equal 382. So I'm going to write 382 is equal to 4/3 pi r cubed. To solve this problem, I strongly recommend that you solve it in a couple of steps, and that's to avoid any issues. The first thing I'm going to do is I'm going to multiply both sides by the reciprocal of 3/4. And what that's going to do is the multiplication of 3 will eliminate the division of 3, and the multiplication of 4 will eliminate the division of 4. And 382 times 3/4, that's going to be equal to 286.5. And this is equal to pi r cubed. So now what I'm going to do is I need to get r cubed alone, and now I'm going to divide both sides by pi. By doing that, if I were to put this into my calculator, this is going to be equal to 91.2 if I round it to the nearest tenths. and that's going to be equal to r cubed. Now, obviously 91.2 is not a perfect, so what I'm going to do now is I'm going to put parentheses around both sides, and you could take the cube root, but to help us use our calculator, I'm going to raise both sides to the 1/3 power. The multiplication of 3 eliminates the division of 3, leaving me with just r. And if I were to put 91.2 raised to the 1/3 power in my calculator, I'm going to end up with 4.5. So 4.5 inches is going to be equal to what my radius is. And that is the end of this lesson. If you have any questions over anything that I talked about, please feel free to email me. Otherwise, I hope you have a wonderful day.